Everyone have the homework? Okay. So I know it's hard to read on the homework, but I will show it to you on my screen and we'll talk about reading all of the sextants. So I think we have, wow, I did 16 practicing reading the sextants. Gonna be real good at this, aren't we? Okay. I am in a new room, if you guys didn't notice. I moved everything out of my kitchen because my husband came home. So I'm hoping that the lighting is still okay in here. I brought extra lighting, but if it gets too dark, I can move out to the kitchen again. Okay. So for the first 15 questions, we are just practicing reading the sextant. Or no, for the first 12, we read the sextant, and then the last 4, we practice our index error, reading our index error. So I'm going to bring up number 1. It's a little bit bigger. Is that easier to see? Or you could read it on your paper.
Yes, that's easier.
Okay. So I'm looking at it. I'm going to say it's, you know, in between 29 and 30 degrees. So I start there. So I'm going to say 29 degrees plus my 0 is at the bottom on this sextant. So I'm going to say it's, well, we have 50, 45. So I'm at 45, 46, 47. So I'm in between 47 and 48. Kind of halfway in between. So I would call that 47.5. You guys agree with that one? All right. Scoot over here. And maybe you guys can do this with the PDF version on the Google Classroom if you want to zoom in on it. Okay, so this is that funky sextant, but we are at 51 and some change. So I'm going to say 51 degrees. And then my 0 is in between the 25 and the 30. So I'm going to say it's about 27, almost 28. So now I need to figure out which one of these match. Which one matched for you guys?
The 0.6.
0.6. So I would call it 51 degrees, 27.6 is my HS.
Okay, so I have a question. How do you determine which one matches? Tim gave a really easy, quick answer there, but how do you know which one matches?
So your 0.2, that one is not in line, right? You can see that?
So you're just looking for a line that lines up.
0.4 is not in line. 0.6 is in line.
Okay, got it. Thank you.
Not quite in line.
Yeah, Frank, you don't care what line it lines up with. You're just looking for one of those on the right side to line up.
Yeah, any line.
Got it. Thank you, Tim.
Okay. All right, so number 3, we have about 20 degrees. From this picture, I don't really know if it's 19 or 20 plus. When I look over here, my 0 is about 15. So I'm gonna say that's 20 degrees, 15, really close to the 15. So I'm kind of seeing is the 0.2 or the 0.8 lining up. 0.2 is kind of lining up. I want to say it's going to be 15 even. That's most.
All right. Now I'm confused because now that Tim taught me that, then the very next one has 4 options that line up. How would you pick which one is up closer?
Which ones are you saying line up? The 0.2?
The 0.2 and then the one at the bottom below the 8, that looks like it's dead on.
So that dead on means that it would be the solid number, meaning the 0.0. So the one past the 8, does your guys' sextant, where'd my sextant go? Have one past 8, or does it just go to 8? 0, 2, 4, 6, 8. So it does have the 10.
And why would you pick 0 over 2 in that case? They're so close.
Because I think the 0, so this is going to be up to you. You know, this is your sight, your vision. So if you saw it and you're like, oh, I think it's a slight higher or slight lower, maybe that will have something to do with it. But again, this is a very small accuracy thing, that if you are off by 2.2, that's as close as you're going to get. But in my mind, this zeros line up and this bottom one lines up. So that means it would be the solid, the 0.0. Because this, again, is 0.0. So it goes 0, 0.2, 0.4, 0.6, 0.8, 0.0.
Okay, thank you.
Okay. Let's go to this one. Let's get all these funky ones out of the way here. Oops. So I'm about 45 degrees. And then I have it just shy of the 15 is where my 0 is. So I'm at 45 degrees, 14 point. All right, Frank, which one do you think lines up on this one?
Oh, you're killing me, Bree. You're killing me. The 4 looks close. The 5 looks close.
I'm going to go with the 4.
Okay.
We got the 4 is the close one on that one. But, and the more, and maybe this would be good practice for you, to when you see one, try to match it on your own sextant and move it one way or the other to see if it's closer to the 2 or closer to the 4. If you move that dial and see things line up differently, that can help with reading it, or getting more comfortable with reading the sextant. Okay, let's go back to this one. Woo. Okay, so on this one, number 5, we are at 35. 35.0, and I'm gonna call that 35.0. So it's real close to 0. That's as accurate as we're gonna get.
Yep.
Okay. Here's this guy. We have 25, 28, between 28 and 29. Ballpark in that. So I'm at 28 and my 0 is at the top. So I'm at 28.42, pretty close to the 43. So I'm assuming my line's going to be lined up in the bottom section, a higher number, because I feel like that's pretty close to the 43. So I'm at 42, 2, 4, 6, 8. I'm going to say that 8 is lined up. So I'm at 42.8. All right. Any questions on that one? Chugging through this. Okay. Let's go to the next page. Okay, so this is a different sextant that we haven't seen yet. but same type of reading. We have about 22, right? About 22. And then our 0 is at 1, 2, 3, between 3 and 4. So we're at 22 degrees, 3 point, and I'm going to go with the 0.4. Okay. Let's go to the next one here. We are back to our OCC sextant. We have a 70 degrees, 71, 2, so somewhere around 72 degrees. And we're on the positive side of 0 here. So I am 72 degrees. And then my 0 is in between the 4 and the 5, pretty close to 5. So I'm going to say it's 4 point something pretty high. That 8 line isn't, no, I'm going to say the 6 line is lined up pretty good. So 2, 4, 6. Yeah. So I'm going to say 72 degrees, 4.6. Okay. Let's go. Oh, I have to go back this way. Ooh. Okay, we got another one here. We have 45, just about 48 degrees. And then we have 15, real close to the 16. And I'm going to call that 16 even. So we got 48 degrees, 16 minutes. Okay. Back to our OCC, Davis. We have 10, 15, 16, so we have 16 degrees. And then here we have 40, 45, so we have 44 minutes. Kind of close to the 45, but let's see if we have one that lines up. What are your guys' votes on this one? 44.8. I'm going to say 8 too. 44.8.
Yeah, the book has a typo where it shows 11 degrees instead of, oh no, it is 11. Never mind.
No, it's 16.
Yeah, but it says 11 in the book, so it's wrong.
Okay. Gotcha. There we go. Thank you for that. Okay, last two on this one. All right, we have 70 degrees, 73. So we're in between 73, 74. So we have 73 degrees. And then we have 31, 2, 3. So 70, 73, 33. And then which one do you think lines up?
4.
4.4. We're going to say that line lines up. All right, last one of these. I'm going to try to get it here. Okay, so we have 40, 45, right about 48, 48, 15, pretty close to 15, but in between 15 and 16. What do you guys think it's closest to?
Dos.
2, 15.2. All right, you guys are going to be dreaming of these little white and black lines, aren't you? Going cross-eyed looking at them. Okay, So those are reading our HS, our raw sextant altitude. So typically, when you're shooting, you get it to where you want it, and sometimes if you want to be super accurate, you can say like mark and have someone else mark the time for you, or typically you just put it right where you want it and then immediately look at your watch and then write down that time, hours, minutes, and seconds, and then you could flip over the sextant and read what the sextant says. And that's the two things that you get. The thing that we do before we shoot is our index error. So that's what we're going to practice here. What is our index error? So again, we have it either on the arc or off the arc. Is it on the plus side of 0 or on the negative side of 0? And I think, Ted, you had said in the comments there that for the plastic sextants, you want to do it before each star?
For each site, because it changes so fast if you're in the sun, because the plastic expands very quickly.
Yeah, so the you can get your index error by, you know, swinging the arc on the horizon really as many times as you want to really fine tune your site. So where you're creating that baseline of 0 for what you're reading. So here we go. We're going to try to find our index error. Okay, so on this one, I could kind of see, let me see if I could zoom in a little bit more. All right, that's as much as I could zoom in. I could see I'm on the negative side of 0. So I'm going to be what they call off the arc. So when I read my number, I would call it right even with that 44, right? So it's pretty, that 0, so we're still going from our 0 line. Our 0 line is pretty dead even with 44. Now my index error isn't 44 degrees off the arc. It would be from that 60 to where that 44 degrees is. So my index error would be 16 off the arc. Does that make sense? Let's do a little, oh, I didn't even have this. Okay. Let's try to zoom in on this guy.
And Bree, you're adding off the mark and then subtracting on the arc. I'm sorry, arc.
You're adding when it's off the arc.
Okay.
Yeah. Okay, so here's our 0. From this picture, it's hard to tell if it's on or off the arc. I'm gonna say it's closer to off the arc. And my 0 is in touching the higher numbers, so I would agree that that would be off the arc. So my 0 would be about 45, 46, somewhere about 46 and a half, but let's see what we come up with here. Here's the 2, here's the 4. So I'm going to call it 46.4 is what my reading is. So then I need to convert that to what my actual index error is from 0. So how far is that reading from 0? I don't think I did my math.
13.6.
13.6. And this one's 16. Okay. Now let's do another one. Wow, all of these I did off the arc. Okay, last one I did was on the arc. Okay, this one we're pretty far off the arc. We are past 2 degrees off the arc, but what I'm going to read is a high number. So what I'm reading is, you know, kind of that -2, but then I go this way. So it's kind of in between 2 and 3 degrees off the arc. And then I have 50 minutes exactly. So I'm 2 degrees, well, so I'm 2 degrees and 10 minutes off the arc. Do you see how I got that? Do I need to explain that better? So I'm at least 2 degrees off the arc, and then within this minute, I have a 50. And in order to get that 50 all the way to 60, I have 10 minutes. So I have to add 10 minutes to get it to 2 degrees flat. So I'm 10 minutes away from that -2 line, if you will. So I'm 2 degrees and then 10 minutes away from it. And how I'm reading that 10 minutes is because I have the 50 there. The 50 goes from the line to the right. So it's 50 from the right, 0, all the way up to 50. But now, because I'm measuring off the arc, I'm measuring from the left to get my 2 degrees to 10. Did that make sense? Okay.
So what does that make your dip then?
My index error would be 2 degrees 10 off the arc. 2 degrees 10 minutes off the arc. Okay, our last one here, we have on the arc. It's on the plus side of 0. So I'm at 1 degree in between the 1 and the 2. So I'm at 1 degree, and then I need to figure out what this is reading. So I have 20, 21, between 21 and 22. Almost to 22. So I'm going to see which one of these line up. I'm going to say that 0.8 does. So I'm at 1 degree, 21.8 on the arc. So I would be subtracting this, because this is where my 0 is. But whatever I read is going to be, you know, 1 degree, 21.8 plus. So then I need to subtract it. All right, any questions with reading index error? We're gonna get that before we shoot. If you are doing exams, it's gonna be given to you in the question. Okay, so now we're gonna dive into the almanac and do our HS to HO. Okay, so get the homework out. Okay, mine didn't print. I think this is it. Tell me if this one is wrong. Our HS we got was 64 degrees, 23.6. Was that right?
Yep.
Yes.
Okay. And it told us our index error was 0.4 off. 0.4 off. So if it's off, I need to put it on. So I'm going to add it. And then dip, they told us the height of eye was 66 feet. So I'm going to go to the dip table and find 66 feet. What do you guys get for dip?
Minus 7.9.
Minus 7.9. So then I'm going to apply those corrections to get my HA. So I have 23.6 plus 0.4 minus 7.9 equals, I have 64 degrees, 16.1 minutes. That is my HA. Then I'm going to go back to my A2 table. We had the sun, and it was May 16th. So I'm going to be between the April and the September. And my apparent altitude was 64.16. So I'm going to find 64. If you could see. Between 61 and 67. So I have a correction of 15.5. You guys follow that one?
Yep.
Okay. Plus 15.5. So I have my 16.1 plus my 15.5. 16.1 plus 15.5, and I get 64 degrees, 31.6. And that is my HO, which then I can compare to my HC and get my intercept. And that's what we're going to do next week. Any questions on getting HO?
Nope.
All right, let's do 60. Okay, so our HS on this one, we had 59 degrees, 55.8 minutes, and we observed the upper limb. Our instrument error was 0. They gave us that. Our index error was 1.1 on the arc, so I have to take it off. I'm going to subtract it. And then our height of eye was 50 feet. Our HP was 54.8. Just going to write it right there. Okay, so now I can go to my table to get dip. My dip for 50. What do you guys get a dip?
Minus 6.9 minutes.
Minus 6.9. Okay. So then we need to calculate our HA. $55.8 minus 1.1 minus 6.9. And that gives us 47.8. So we have 59 degrees, 47.8. Now we're going to go to the back of the buck minus all those abs. And I'm going to zoom in on this. Okay. Focus it. Okay, so we have an apparent altitude of, what was our parent altitude? 59.47. So we had 59, so we're in the 59 section. And then we are at 47 minutes. Oops, you can't see it. So we are at 59. So I'm going to be somewhere in this section, right? And then for my minutes of my apparent altitude is on the side. So my minutes were, shoot, what were my minutes? 47.8. So I'm going to be somewhere in between these two. And I have a 39.2 and a 39.1. Now I was 47.8, so I was a lot closer to that 50, right? So I'm going to use 39.1 as my correction. Okay, so I'm going to write that one in here. There we go. What did I say? I said 39.1. Did everyone see how I got that? We're going to add that correction. Weird lighting here. Okay, so then same column we're going to follow. We're still in this 59 column. We're going to go in with our HP correction. So our HP, what was it? 54.8. So we're going to find 50. Let me get another thing here. 59.8. Oh yeah. No, 54.8. Sorry. 54.8 is going to be pretty dang close to that 54.9. And we did the upper limb, right? So we're going to do the 29 or 2.9. If I did the 0.8, it would be, or 0.6, it would be 2.8. So I'm pretty close to the 54.9. So I will call that 2.9. Everyone see where I got that? Okay. We're going to add those corrections. And then if it is the upper limb, which we have the upper limb, we're going to subtract 30. Everyone see where I got those numbers?
So your little minus 30 was from the little moon correction table?
Yes.
Okay.
Because it's the upper limb. All upper limb sites, oh, you can't see what I read there. All upper limb sites are minus the 30. So I have my 48.7 plus 39.1 plus 2.9. Let's bring this back. Okay. Let me get this worked out here. So that was our site reduction for the moon. So we didn't use those A's, we just used the moon corrections in the back. Any questions on the moon?
Just a quick refresher. We're given HP. What is that?
That is on the daily pages. When you have your GHA, your declination, and then your HP. And that's that horizontal parallax because the moon is so close to the Earth.
I got it. Yep.
So yeah, those are on the daily pages. Okay, I'm gonna erase this one. Okay, so number 17, we're doing the sun. And we have on this one, we have an index or an instrument error, excuse me, which typically you're not gonna have. For some reason, I threw it in here. But we do have a very low sight, 6 degrees, 12.3 minutes of the lower limb. Instrument error was 0.4 low, so we have to add it. Index error was 3.2 off, so we have to add it. Dip, our height of eye was 20. And that's all we got. Okay, so we go in first with our dip. Our height of eye was 20. Focus. What is our dip for 20?
Minus 4.4.
Minus 4.4. Okay, so now we can calculate our apparent altitude. We have an apparent altitude of 6 degrees, 11.5 minutes. In order to get our A correction, we have a low altitude. So we're between that 0 and 10 degrees. We are 611.5. So we need to follow, let's see if we can do this one. Our 6, so we need an apparent altitude of 0 to 3, 3 to 6. So here's our 6th section. Let's see if we get that there. Okay, so we have, what's our number again? 11.5. So we have 6, dang it, and we have 10 and then 20. So we're pretty close to that, that 10 at 11.5. But let's see what our numbers work out to be. So we shot this in October, which would put us in this column. And we also shot the lower limb. So that's going to put us in this column. So we are, let's see, we're between 7.8, 8, and 8.2. And my apparent altitude was 611. So I'm going to go with 8.0. So that is a plus 8.0. Okay. And now we add our correction. So we have 19.5, 6 degrees, 19.5 minutes as our HO. So that was number 17. Any questions with using that A3 chart? All right.
Yeah, I have a question.
Yeah.
It's not the A3 chart, it's the dip.
Yes.
20-foot dip
Yes.
is how much?
Is 4.3. What did I say? 4.4.
Okay.
20-foot dip, yes, would be between that 19.1 and 20.1. So I would actually call that, you're right, 4.3.
Okay.
So this would be 4, and this would be 4. Good eye. Does that make more sense for you, Robert?
It should be 11.6 and 19.6. You
Did I do it
subtracted
wrong?
one. You subtracted 1/10 less,
Oh gosh,
so it should be bigger.
yeah, you're right.
Okay, got it.
There we go. Now we're cooking.
All right.
Okay, let's do number, and we're doing the sun. All right, so our HS, 18, HS is 15 degrees, 33.3, and that was the upper limb. Index error was 0.9 on, so I have to take it off. I'm going to subtract that. My height of eye was 31. I have a temp of 70 degrees and a pressure of 1010 millibars. Okay, so I need to find my dip first for 31 feet. What did you guys get? I got 5.4 as my dip, so now I can calculate. $33.3 minus 0.9 minus 5.4 gives me 27.0. 15 degrees, 27.0 minutes. That's my apparent altitude. Then I go to my A2. Nope, it's on here, sorry. My A2, I observed this sun in March. So that's going to put me on the October to March. And I observed the upper limb. So I'm going to be following the upper limb column. My apparent altitude was 15 degrees, 1527. So we have a 1505 and a 1531. So my upper limb would be at a minus 19.5. Okay.
I'm confused. Oh, no, that's right. Okay, I see. I see. I got it.
It was the upper limb.
Got it. Yep.
And then we go to our A4. We're going to do our temperature pressure, A4 correction. And again, we go in with our apparent altitude, so that HA. Find my other little ruler here. I'll use these guys. Okay, so I'm going to go in at 70 degrees. So here's my 70 degrees in Fahrenheit at the top. And then I'm going to go at my 1010. Is right where, pretty much right where that little plus sign is. You can, you know, make a little pencil mark if you want. Right there. So I am in column J. So I'm going to follow the J down. Oh, and temperature in Celsius is at the bottom if you want to, if you add that. That's cool. Okay, so
Wait, you're not in column H? At 70?
70 and 1010. So I had 1010 and 70. Yeah, I'm in column J.
Okay, but J's over in the 80 degree.
So
column.
you don't follow those diagonal lines until you get you have straight lines. You see on my
Oh, got it. Okay, use the horizontal and vertical.
so yeah, I've straight
Okay.
down from 70 and
Okay.
then straight across from 110.
Thanks.
And then where that meets, now I'm in J. And now I can follow the J column.
Got it. Thank you.
Okay. So our parent altitude, geez Louise, what is our parent altitude? 1527. So I'm going to go down to following J. Our parent altitude is 15 degrees. So it gets smaller and smaller as as we get higher. Our sun gets higher in the altitude. It'll be affected less for refraction on the horizon. Anyway, so we have J, and then we had 15. So our correction would be 0.1 plus 0.1. Okay. So we have plus 0.1. And now we can calculate our HO. 27. Here. There we go. 27 minus 19.5 plus 0.1 gives me 15 degrees, 07.6 minutes as my HO. Any questions with that one? All right, let's do our last one here. Our HS was given to us at 38 degrees, 18.7. Instrument error was 0. Okay. Index error was 2.4 off. So I'm going to put it on. Dip was 18 feet. So or height of eye was 18 feet. What is our dip correction? Throw it out there.
4.1.
4.1. And we always subtract our dip. Okay. So we can calculate our HA, our parent altitude, plus 2.4 minus 4.1. 17. 38 degrees, 17.0. Then on our A2, we are in the star section. So our apparent altitude was 38. And down here I have the 37 and then a 40. So my 38 would fall at minus 1.0. Sorry, 1.2. So that gives me 38 degrees, 15.8 minutes as my HO. All right. What do you guys think of this so far? We're 3 weeks in. What are we? More than halfway, almost halfway. A lot of information.
It's just remembering which tables to go look at.
Mm-hmm. So hopefully your site reduction table or sheet, whatever I have, print mine out, use that hard plastic one, will kind of, you know, trigger that memory of like, oh, A1, A2, or trigger all of these little corrections. You know, they're not, you know, trig or complicated math. It's just adding and subtracting, but they're just little tiny mistakes that can add up. Or looking, you know, in the wrong column. I should have added, I should have subtracted, so I'm 90 degrees off, or, you know, getting a wrong number that way is another common mistake. But I think we're doing good so far. Next week, we're going to do that last bit of the site reduction form, which is in Pub 229. So Pub 229, there is, okay, my Pub 229 doesn't look too great, but is there a cover page on? Okay, so volume 2 is 15 to 30 degrees latitude. And so our practice problems are going to be out of volume 2. We are currently above that. So for our practical, you'll need the volume 3, which is 30 to 45. But again, this is online. So if you have volume 2, just practice using volume 2 with our practice exercises. And then you can use the online one for the practical sites if you want. Or it's like, I'm sure it's like 20 bucks or something on Amazon. So next week, we're going to dive into the new pub. So we've mastered the almanac, right? We know this thing inside and out. Now we're going to add another book. Now we're going to add this guy. So yeah, next week, and we're going to actually plot it. So we're going to also use our universal plotting sheets, which I can't reach an example of right now. But those universal plotting sheets, we're going to practice on those as well. Yes, Tim's got it. Oh no, that's a maneuvering board. That is not a universal plotting sheet.
They sold me the wrong ones at the OCC.
Oh no!
So, Bree, if you wanted to get commercial site reduction forms, which ones would you might suggest?
I would suggest using the one in the book. So either the example in the almanac or in the site reduction table, which I will show you.
Okay. Which you're looking through the 229.
Yeah.
So I'm not sure I remember seeing a form in here. I mean, they give examples, but it's not really a form.
Yeah. Maybe.
You know, I was thinking of something like Weems and Plath or
The azimuth one is in here. That's what it is. Okay. Yeah. So where is, hold on a second.
The reason I'm asking is everyone seems to do it a little bit differently, and let's see if I can find forms that approximate the flow that you've been using.
I'm gonna say I think this one follows mine pretty close. This is the Davis quick reference sheet, and this is their site reduction form.
Okay. Do they make forms, or we just have to make them themselves from that one?
You just make it yourself from that one. So yeah, you can either, make your own and print off sheets, or you're working out of, a lined notebook and you're writing your notes in a lined notebook.
Got it.
With the plastic on this one, it's really easy to use a magic marker and then just like a dry marker and then erase it right off this plastic.
Yeah. They have an example on there, so that's pretty cool. So this one, is for the sun. So again, it doesn't have that extra correction for the moon, or does it have the extra correction for Venus or Mars? No. So sometimes you'll have to add in a line. And that's where if you're using, a lined piece of paper and adding in your stuff as you go, you can kind of add in those things. But again, like, am I going to remember to add in those things? That's the tricky part. Like, Bree told me I had to add in things.
I think that if you're on a trip and you know that you're going to be taking particular sun sites or moon sites, star sites, whatever, you develop a form that works for you. And some of the things like dip, it's almost always going to be the same.
Absolutely.
So you can, maybe you don't want to print it in, but you always want to put a reminder there of what it should be. I mean, there's some things that
you don't have to look it up every time. If I'm
every
on
day
the
they're going to be the same.
This, I'm on the back deck, it's this.
So you can kind of build those into your own personal worksheets.
Mm-hmm.
The other thing is, one of the students said he had the wrong plotting sheets. Is that correct, or?
Yeah, apparently I have the maneuvering board, and what am I supposed to ask for?
Do you have it? Can you hold it up?
Does that work? No.
No.
Oh, that is, yeah.
Yeah.
Okay. We also have the order form said universal plotting sheets, and when I put orders together, I thought that's what I put in the order. We can exchange those if you'd like.
Okay, thanks.
Or send you more.
Yeah, no, I'll stop by and just.
So it's Tim?
Yes.
Okay, Tim, I'm not back in the office again until Monday, but I'll write myself a note to actually I'll call the office tomorrow and see and explain what happened.
Okay.
So and then I'll have the office call you.
You're awesome. Thank you.
Let's see. Okay, so I wanted to show you guys when we're kind of creating what site reduction form you want to follow. I'm going to show you our Google Classroom again. Where did it go? Okay. So our Google Classroom, on our Breeze quick references. So this is, what I've come up with, and you're welcome to print out. For the site reduction forms, that's just part of it, right? That's just part of the site reduction form for the sun and the stars, the planets and the moon. But I have done it this is the one for the star. And remember, our LHA is different because we are going from Aries to the SHA to GHA. So that's a little bit different than the sun. But other than that, the stars, you may or may not have an additional correction. So I added that one in there. But other than that, it's the same. For the sun, that's the basic one that we're kind of working off of. You don't have the star for the GHA. You have what we've been working on for H to HO. And then the 229 one's the same for everything. Oh, this is where I put that. I was like, I know I put it somewhere. Our latitude by Polaris site reduction form, we're going to be using on the final week. It's just the latitude line. So this is the site reduction form for that one. So I kind of made different ones for each thing that I think you guys would be doing. So you're welcome to, again, that was in the Google Classroom Breeze quick references. I don't know what I'm doing. Here we go.